A field researcher studying lion behavior in the Serengeti documented an encounter in 2016 that her team spent months trying to categorize. A male lion, dominant, well-fed, territory, established, approached a stopped vehicle at the edge of a waterhole. Standard protocol. Windows up, engine off, no sudden movement. The two researchers inside followed every guideline correctly. One of them was terrified. The other was not. The lion walked the full length of the vehicle on the passenger side, the side where the frightened researcher sat, paused at the window for 11 seconds, then continued around the vehicle and walked away. It did not approach the driver's side at the same distance. It did not pause at the driver's window. The researchers had identical training, identical stillness, identical silence. The only measurable difference between them in that moment was internal. And the lion apparently read it through a closed window. Start with what fear actually does to a body. Fear is not an emotion that stays inside. The moment the human threat response activates, it begins rewriting the body's chemistry in ways that are detectable far beyond the boundaries of the skin. Adrenaline floods the bloodstream within seconds. Heart rate climbs. Blood pressure rises. Sweat glands activate, producing a chemically distinct composition that differs measurably from sweat produced by exertion or heat. The body's temperature regulation shifts. Micromuscle tremors begin in the hands and legs as the fight or flight system primes the body for movement it has been told not to make. Every one of those changes produces a signal, and predators did not reach the top of their respective food chains by being poor at reading signals. The chemistry of fear sweat has been studied in enough detail to produce results that most people find uncomfortable. In 2009, researchers at Stony Brook University isolated compounds in human sweat produced specifically under psychological stress and compared them to sweat produced by the same individuals during physical exercise. The chemical profiles were distinctly different, not slightly different, different enough that trained detection animals could distinguish between the two samples with accuracy rates above 90%. The compound responsible is androstenone, a steroid derivative that appears in elevated concentrations in stress sweat specifically. Animals with functional olfactory systems, which includes every large predator on Earth, can detect androstenone at concentrations far below what any human instrument in a standard field setting could register. A lion does not need to see a trembling hand. It does not need to hear a quickened breath. It can read the fear from the air itself. Heart rate adds another layer that researchers have only recently begun to quantify. Large predators, particularly cats, possess low-frequency hearing ranges that extend well below the threshold of human detection. A lion's hearing is directional and sensitive enough to locate prey through dense vegetation from distances exceeding a kilometer. At close range, that same auditory sensitivity operates on a different scale entirely. A human heart rate elevated by fear produces a sound profile measurably different from a resting heart rate. Not different in ways humans can hear each other's hearts, different in ways that a predator positioned within close range in the silence of a stopped vehicle at a waterhole can detect through a closed door. The 11-second pause at the passenger window was not coincident. Something in the signal profile emanating from that side of the vehicle was different enough to merit extended investigation. But here is where the research produces a finding that almost nobody discusses outside of behavioral biology literature. Predators do not simply detect fear. They respond to it differently, depending on context. A lion that detects fear signals from prey it is actively hunting responds with increased pursuit behavior. The fear signal confirms prey status and accelerates the predatory sequence. A lion that detects fear signals from an unfamiliar large object. It is investigating responds with something closer to heightened curiosity and prolonged assessment. The fear signal in that context does not trigger pursuit. It triggers extended information gathering. The predator is asking a question. Why is this thing afraid? What does this thing know that I don't? Fear detected from a novel stimulus raises the predator's own alertness. Because in a landscape where everything is either predator or prey, a large, unfamiliar object that is producing fear signals either knows about a threat nearby or is itself a threat performing an unfamiliar behavior. Neither interpretation leads the predator to dismiss the signal. Both interpretations lead it to pay more attention, which brings everything back to that lion pausing for 11 seconds at a closed vehicle window in the Serengeti. It was not being menacing. It was not preparing to attack. It was gathering information about a signal it had detected that the signal's source was trying very hard not to produce. The researcher's training told her to stay still. Her body ignored that instruction at a chemical level and continued broadcasting regardless. And the lion, operating on sensory systems refined across millions of years of reading exactly this kind of signal, stood at the window and listened to everything her body was saying. Predators do not know you are afraid the way another human knows. They do not read your face or interpret your expression or recognize the cultural signals of human fear. They know you are afraid the way a storm knows a barometer is dropping, not through understanding, through direct physical detection of a measurable change in the environment around them. The fear was in the air. The lion read the air. Everything else about the encounter was theater